right, so as we talked about last lesson, this system of prefixes is super important in organic chemistry, and we will be using it time and time again. Now, how does this apply to alkanes? Well, before we get there, we need to take a look at a couple of things about alkanes, such as their general formula. So alkanes have a general formula, CnH2n plus 2. What does this mean? All it means is that if there are a certain number of carbons in a compound, so N stands for number, then there are 2 times that many plus 2 hydrogens. So for example, if you had 6 carbons in a compound, then you would have 2 times 6, which is 12, plus 2, so 14 hydrogens. So therefore the molecular formula would be C6H14. The other thing that we need to know about alkanes is that they are what we call saturated compounds. Now, saturated compounds has a couple of definitions for it. It has kind of the technical, sciencey definition, which is each carbon has the maximum number of hydrogens bonded to it. And then it has my definition, which makes sense or makes things a lot more quick, for me anyways, when I'm looking at things or looking at a compound and trying to determine if it's saturated or unsaturated, which we'll see later. So a saturated compound has only single bonds. So only single bonds between carbons, and then of course only single bonds between carbon and hydrogen, because hydrogen can only form one bond. Just to spice things up in organic chemistry, we have different types of formulas. So there's the 4 listed there. Molecular formulas, guys, are what we've seen before, what you've seen for every, I guess, compound that you've looked at. I just mentioned one, C6H14. So if we wrote that down, that would be a molecular formula. Okay? Then in organic chemistry, we get things a little spicier by having different kinds of formulas. So structural formulas, condensed structural formulas, and line structural formulas. The reason that we have those other formulas, structural formulas, first of all, show how things are bonded together. And as we're going to see in organic chemistry, it's really helpful to know how things are bonded together. Okay, condensed structural formula came about because scientists are lazy and they got tired of writing so many H's all the time. So we'll see momentarily how that makes writing a structural formula a lot more easy. And then lastly, line structural formulas or line diagrams are the height of laziness, and that shows, or they show CH groups replaced with lines. We're going to see these. Okay. So, example here, write the molecular, structural, condensed structural, and line diagram for each of the following. Now, what I recommend you guys do is let's do this first example together, propane, and then pause the video as you work through the next 2 examples, and then come back and I'll have the answers done. So propane. Pro, that prefix, tells us that there are 3 carbons. If I use the general formula, I know that for hydrogens there will be C3, H, 2 times that number, plus 2. So 2 times 3 plus 2 is 8. So the molecular formula for propane is C3H8. Now, structural formulas. What I want to do is I want to show how all these C's and H's get bonded together. Things you have to know. Number 1, carbon must bond with 4 things, or it must have 4 bonds coming off of it. Secondly, hydrogen can only bond with 1 thing. Okay? Now, if hydrogen can only bond with 1 thing, then it makes sense that hydrogen's only bonding with carbon, not with another hydrogen. Otherwise, that would just simply be a molecule of hydrogen and not part of this compound. Easiest way is if I start by showing the C's bonded together in a chain like that. So there's my 3 carbons. They're going to all bond to each other. Now, each of these carbons, as I said, has to have 4 bonds coming off of it. So I'm just going to draw those in right now. Okay? Now I have to figure out, well, how do I put 8 hydrogens around here? And magically, these bonds coming off the carbons that I drew, because I knew each carbon had to have 4 things bonded to it, are all bonded to H's. Okay, so that's our structural formula. Condensed structural formulas basically are a shorthand way. So instead of, and you'll figure this out when you're doing your homework, instead of writing C's and H's all the time, this gets a little bit redundant. What if we wrote this as CH groups? What do I mean? Okay, well, I mean, let's take a look at each carbon and the hydrogens that it's bonded to. Okay. Now, how can we translate that into a condensed structural formula? Well, instead of writing the C and then bonded to 3 H's, I'm just going to write CH3. Okay, so this CH3 corresponds with that group there. What is that bonded to? Well, that's bonded to a CH group, that's the guy in the middle, which is then bonded to a CH3 on the end again. So if you need the arrows, this is going to get a little messy, but that's okay. That's where all of those CH groups came from. So as you can see, that's a little bit easier, or takes up less space. You have to write fewer things. Takes up less time, which is what we're mostly interested in. A nice, easy way of writing the condensed structural formula for propane. Lastly, we have line diagrams. Okay, line diagrams. I don't like these, so probably my bias comes through. Somebody came along and they said, well, I'm really lazy actually, and writing letters at all is far too time consuming and difficult for me. And so they said, well, what if we replace each CH group with a line? Oops, I'll make that in blue. There we go. Okay, well, isn't that exciting? So that one line represents a CH group, kind of. But then people said, well, that's ridiculous. We don't walk around, like, how are we going to decide? We don't have rulers in our pockets at all times. If it's a propane, do we draw a line that's 3 inches long? And if it's a methane, so 1 carbon, we draw a line that's 1 inch. And it was decided, well, actually, what we're going to do is we're going to angle these lines. And so for each line segment, I'll just make this one a little bit thicker, that we draw, okay, there is considered to be a C at both the start of the line segment and the end of the line segment. So I drew 2 line segments. That represents 3 carbons, or 3 CH groups, I should say. So this here would be a C, this here would be a C, and this here would be a C, and then bonded to their appropriate number of hydrogens. Now we don't draw in what I've just done in green there. We don't draw in the C's or the arrows. It's just simply, I'll redraw this. The line structural diagram or line structural formula for propane simply looks like that, like the roof of a house. I know it seems a little bit ridiculous, and I think that it truly is for alkanes. It does have its place when we move into cyclical compounds and benzene and all that kind of fun stuff. So what I'd like for you guys to do is please pause the video right here and then move on to do your next 2 examples. Again, molecular formula, structural formula, condensed structural, and line diagram. And then I will put these up and we can check and see our answers. So our next example was octane. Oct means 8, so C8, and then 2 times 8 plus 18 plus 2, pardon me, is H18. So when we draw the, I'm going to go off the slide for this one because it gets a little big. When we draw the structural formula, okay, you can see that this gets quite large. Now, when, and only when, you've been doing organic chemistry as long as I have, it's acceptable to actually just draw the structural formula like this. I haven't written my H's. However, in organic chemistry, it's accepted practice that if you have just kind of a bond coming off carbon, not indicating that it's to anything specific, it's accepted practice to know that that means it's bonded to hydrogen. Even still, even if you don't draw the 18 H's, which I'm not going to, because I am lazy, it's still far less time for you to do the condensed structural formula. So what does a condensed structural formula for octane look like? Well, at the end of the molecule, at the end of the chain, I've got a CH3 group, and then I have 6 CH2 groups. 2, 3, 4, 5, 6, 7. And then at the end, or at the other end of the chain, is another CH3. Now, if you want to get really fancy, and only if, so this answer that I've written is completely acceptable, condensed structural formula. You can condense that actually even further. And I don't know if it has a technical name, but I call it the condensed structural formula. All I'm going to do is I'm going to replace these 6 CH2 groups. So I keep my guy at the end, CH3, and then I'm going to indicate that there are 6 CH2 groups in the middle bonded to another CH3 at the end. Now, you don't have to do that. You might see that in your homework, so I just wanted you to be familiar with that. That saves even more time. Finally, what does our line structural diagram look like? Well, I'm going to have 7 line segments, 2, 3, 4, 5, 6, 7, and that makes, or that represents 8 carbons. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, again, don't draw what's in green. So just the zigzag line is what the line structural diagram looks like. Okay, last example, I gave you the molecular formula. So the first thing that you guys had to do was come up with the structural formula. And I'm betting that you did this. And then you drew your H's in because you're responsible young chemists. Okay, but I'm not going to. So you did that. I'm willing to bet. I'll put money on every single student did that. Well, let me tell you. Here's what I drew. Clearly, we have not drawn the same molecule. And we know that I am always right. And if you don't believe that, you can go ahead and double check. There are 4 C's drawn there. And then if you check out, if you count all the bonds, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens would be bonded to them. Okay? Now you know that you're right because you have counted 4 carbons, 4 hydrogens in your molecule right here. So are we both right? And the answer is yes. Yes, we are both right. Okay, how can this be? We haven't drawn the same molecule. In fact, you guys drew butane. And I drew not butane. Interesting. So what did I draw and what on earth is going on? Well, hopefully up to this point you've been thinking, you know what, this organic chem seems really easy. And now we're going to challenge you a little bit. So what I have drawn, guys, is what's called an isomer of butane. An isomer has the same molecular formula, so you can look back and see we both drew C4H10. That was a molecular formula. Clearly different structural formulas. Now, because they have different structural formulas, we need to introduce a new concept, and that is talking about continuous chain versus branched alkanes. The alkane that you guys drew is a continuous chain alkane. It's 4 carbons in a row, bonded one to the next, to the next, to the next. The alkane that I drew is a branched alkane. Okay, so you can see that when I have this little guy here coming off of off the main chain, that's what we call a branch. I'm going to give you guys a moment to take a look at the rules for naming, or the steps to follow for naming alkanes. Please read those, and then you can watch part B of this lesson, which goes through examples on how to name branched alkanes.